Welcome to the Ultimate Android Interview Questions Cheat Sheet. In this video, we'll walk through the most frequently asked questions and concepts you need to know for Android developer interviews. Whether you're preparing for your first interview or brushing up on advanced topics, this guide will help you understand the essentials, from application structure to architecture patterns. Let's dive in and make sure you're ready to impress your interviewers with clear, concise, and confident answers. Start with the basics. What is an application in Android? The application class is the base class within an Android app that contains all other components, such as activities and services. It's instantiated before any other class when your app process is created. This means it's the foundation for everything else in your app, ensuring all components have a common context and can interact seamlessly. Understanding this helps you manage global state and resources efficiently. Next, let's talk about context. In Android, context is a handle to the system, providing services like resource resolution, database access, and more. There are two main types: application context, which is tied to the app's lifecycle, and activity context, which is tied to a specific activity's lifecycle. Knowing when to use each is crucial for avoiding memory leaks and ensuring your app behaves as expected. Android supports several CPU architectures, with ARM7 being the most common due to its battery efficiency. ARM64 is a more powerful 64-bit version, while x86 is less common but offers strong performance. Understanding these architectures helps you optimize your app for different devices and ensure compatibility across the Android ecosystem. Why can't Android run standard Java bytecode? Android uses the Dalvik Virtual Machine (DVM) instead of the Java Virtual Machine (JVM). Dalvik is optimized for mobile devices, focusing on low memory usage and battery efficiency. This difference is key to understanding how Android executes code and why APKs are structured the way they are. Gradle build types define how your app is built and packaged. For example, you can specify whether ProGuard runs or which resources are included. Gradle combines build types and product flavors to create build variants, giving you flexibility for different environments like development, staging, and production. Mastering build types helps you streamline your release process. Android build process involves several steps. First, resources are compiled into the R.java file. Next, Java source code is compiled to files, then converted to Dalvik bytecode decks using the DX tool. Finally, the apkbuilder packages everything into the APK file. Understanding this process helps you troubleshoot build issues and optimize your app's performance. Android application architecture is made up of several components: services for background tasks, intents for communication, resource externalization for managing strings and graphics, notifications for user alerts, and content providers for sharing data. Each plays a unique role in building robust, modular apps. Activities are the main entry points for user interaction in Android. Think of them as windows or containers for your app's UI. Each activity represents a single screen, and you can have multiple activities in an app, each handling different tasks or workflows. Activity lifecycle is crucial for managing state and resources. Key methods include onCreate, onStart, onResume, onPause, onStop, onDestroy, and onRestart. Each method corresponds to a specific stage in the activity's life, from creation to destruction. Properly handling these ensures smooth user experiences and efficient resource management. The onCreate method is called once when the activity is first created, making it perfect for initialization. OnStart, on the other hand, is called every time the activity becomes visible, such as after onCreate or onRestart. Knowing the difference helps you place your setup code in the right place. In some scenarios, only onDestroy is called for an activity, skipping onPause and onStop. This happens if finish is called inside onCreate. The system immediately destroys the activity, which is important to know for managing resources and avoiding leaks. It's best practice to call setContentView in onCreate, because this method is only called once during the activity's lifecycle. Placing it elsewhere, like onResume, can lead to unnecessary overhead and performance issues, as those methods may be called multiple times. OnSaveInstanceState is used to store data before an activity is paused, while onRestoreInstanceState retrieves it when the activity is recreated. This ensures that user data and UI state are preserved during configuration changes like screen rotations. Android supports several activity launch modes: standard, single-top, single-task, and single-instance. Each mode controls how activities are launched and managed in the task stack. Understanding these modes helps you design intuitive navigation flows and manage activity instances efficiently. When the user rotates the screen, the current activity instance is destroyed and a new one is created in the new orientation. The lifecycle methods are called in the same order as when the activity was first created. This is why managing state and using view models is so important. To prevent data from resetting during screen rotation, use view models to store data that should persist and onSaveInstanceState for small UI data. View models survive configuration changes, while onSaveInstanceState handles transient UI state, ensuring a seamless user experience. You can clear the back stack of activities using intent flags. Removes activities above the target, while flagActivityClearTask with flagActivityNewTask clears the entire stack and starts a new task. This is useful for navigation flows like logging out. Content providers allow data sharing between applications. They manage access to structured data and enforce security. To access data, use the content resolver object and query methods. This is the standard interface for inter-app data communication in Android. To access data from a content provider, ensure your app has the necessary permissions. Use getContentResolver to obtain a content resolver, then query the provider. The query returns a cursor which you can use to retrieve data column by column. Services are components that perform long-running operations in the background without a user interface. There are three types: foreground with notification, background limited in newer APIs, and bound client-server interface. Services are essential for tasks like music playback or data syncing. A service runs on the main thread and should be used for short tasks or with additional threading. Intent service, on the other hand, handles asynchronous requests on a worker thread and stops itself when done. Use intent service for tasks that don't need to interact with the UI. Threads are used for long-running operations but can't be canceled easily and don't handle configuration changes. A sync task is for short tasks, allows UI updates but isn't suitable for long operations. Choose wisely based on task duration and UI needs. Services run in the background without UI and continue even if the app is destroyed. A sync task is for short UI-related background work. Intent service processes intents on a worker thread and stops when done. Threads are basic units of execution. Understanding their differences helps you choose the right tool for each job. Handlers manage communication between threads, especially for updating the UI from background threads. They receive messages and execute code in response. Handlers must be cleaned up properly to avoid memory leaks, especially when used outside the activity lifecycle. Job Scheduler allows you to schedule jobs based on system conditions like memory, power, and connectivity. It supports batch scheduling, reducing battery consumption. Use it for tasks like uploads, network access, or periodic background work. A sync task isn't tied to the activity lifecycle. If an activity is destroyed, the async task may continue running and try to update a non-existent UI, causing exceptions or memory leaks. For long-running tasks, use services instead to avoid these issues. On-trim memory is called when the system needs to reclaim memory. Implementing this method allows your app to release resources and avoid being killed. It's part of the component callbacks to interface and helps your app respond to memory-related events. A bound service allows other components to bind and interact with it, even across processes. Implement onBind to return an iBinder for communication. Messenger-based services enable inter-process communication without AIDL, making them simpler for many use cases. AIDL enables parallel message passing for complex app-level communication, while Messenger queues messages sequentially for simpler thread and process management. Choose AIDL for advanced data and control sharing, and Messenger for straightforward IPC. A thread pool manages a group of worker threads and a task queue, reducing the overhead of creating and destroying threads. It's more efficient for handling many small, concurrent tasks, improving performance and response time. Serializable is a standard Java interface for object serialization, but it's slower and creates more temporary objects. Parcelable is Android-specific, more efficient, and requires you to implement serialization manually. Use Parcelable for passing data between Android components. Activities provide the user interface, while services run in the background without UI. Use activities for user interaction and services for background tasks like music playback or network operations. To update the UI from a background service, register a local broadcast receiver in the activity and send broadcasts from the service. Alternatively, use handlers for communication. Always unregister receivers to avoid memory leaks. Intents are messages for communication between components. Implicit intents trigger system actions like sending emails, while explicit intents start specific activities within your app. Mastering intents is key for navigation and intercomponent communication. Sticky intents allow data to persist after broadcast, so other components can retrieve it later. Pending intent lets another app perform an action on your behalf at a future time, such as triggering a notification or alarm. Intent filters specify which intents an activity or service can respond to, while actions describe the intent's purpose, like action call for making calls. Properly configuring filters ensures your components receive the right intents. Fragments are reusable UI components attached to activities. They can be used across multiple activities and have their own lifecycle but depend on the host activity. Fragments help create flexible and modular UIs. The fragment lifecycle includes methods like onAttach, onCreate, onCreateView, onActivityCreated, onStart, onResume, onPause, onStop, onDestroyView, and onDestroy. Managing these ensures fragments behave correctly within activities. Activities provide screens for user interaction, while fragments represent portions of UI or behavior within activities. Use fragments for reusable UI components and activities for overall navigation and structure. Use fragments when you need UI components across multiple activities, want to display multiple views side by side, or need to persist data across activity restarts. Fragments enhance flexibility and code reuse. When replacing fragments, use Add to Backstack to allow users to return to the previous fragment with the back button. This ensures intuitive navigation and preserves user history within your app. By default, fragments are destroyed and recreated with their parent activity during configuration changes. Calling setRetaininstance true retains the fragment instance, preserving its state and avoiding unnecessary recreation. Fragment page adapter keeps all fragments in memory, which can use more resources. Fragment state page adapter destroys fragments when not visible, saving memory and handling large data sets efficiently. Choose based on your app's needs. That wraps up our Android interview questions cheat sheet. We've covered everything from core concepts to advanced architecture patterns. Review these topics, practice your explanations, and you'll be well prepared for your next Android interview. Good luck and happy coding.